Hey guys, so today we're doing a 1UZ VVT-i from an LS400 going into an IS200 using a manual gearbox. So let's get into it. Right, as I said, this is a 1UZ VVT-i from an LS400. It's going into an Lexus IS200. He's using a manual J160 gearbox, and it is a complete plug-and-play harness. So, as you can see, this is an original harness that we've obviously stripped, taken everything out that needs taking out, added in what needs adding in, and making it all plug-and-play, as you see in the ECU box there. So, first thing we're going to do is let's take a look at the photographs and see what that process entails. Right, so there you go. You can see exactly what we do. Obviously, we strip the entire harness down. We remove everything that's not needed. Obviously, all the automatic gearbox wiring. We make a whole bunch of new wiring sections to go in, which we'll go through as part of the layout. And then obviously, we create the complete plug and play section over there. Okay. Right, so the first thing we're going to do today is, same as always, we're going to go through the layout first so the customer knows where everything plugs in and how it works. Then we're going to pop off and do the testing, one with the ignition on and one with the engine actually running. Okay. So before we start the layout, what I'm going to do is, obviously it's a bit of a mess here in the half cut on the ECU box. So I'm going to cut to a photograph now and show you what it looks like when everything is nice and neatly tucked away. There you go. Right, so starting at the ECU box over here, it's really, really nice and simple. There's not really much to get wrong. We have a couple of connectors for your ECU over here. So we've got basically 1, 2, 3, 4, 5, and 6 connectors there. Super straightforward. They're all different. You can't plug them into the wrong place. Because the 1UZ VVT-i has a rectangular ECU case, it does go straight into the IS200 ECU box. No modification required there, so super, super simple. Okay. Moving along, we then have our plug and play section over here. So this is plugging into the two connectors that are left behind when you remove the 1UZ-FE engine. That's a 28 pin and that's a 22 pin. So again, completely different. So you can't plug them into the wrong place. So again, super simple, nothing really to worry about there. If I move that out the way, we then have our IS200 body plug. So we've got a gray plug there, black plug there, and a blue plug there. Again, all different keyways. You can't get it into the wrong place. So again, super, super simple to connect it up. Okay. As per usual, we have our ATEMU device on here. So this is emulating the automatic transmission signals to the ECU to keep it happy now that it's no longer running an automatic gearbox. We then have our MPX converter. So again, what this doing is it's taking the MPX data from the 1UZ VVT-i ECU and it's converting it so the IS200 can understand that MPX data. Therefore, all the gauges and everything continue to work correctly. Okay. Now, this harness is a bit of a weird one. It's actually a Japanese Celsius harness, believe it or not. And the customer didn't have an ECU, so I went on eBay, bought one, and it was an American ECU. Now, if you've seen any of my other videos, you'll know that there's some slight differences between the American, the European, and the Japanese ECUs. And so basically, when you have a European or a Japanese ECU, you can happily not connect the secondary Lambda sensors. Yes, it'll bring a code, but it won't cause a check engine light, so it's not really a major issue. We also don't need to connect the resistors for SLU, SLN, and SLT on a Japanese or a European ECU. But unfortunately, the American ones, it will cause a check engine light if you do not connect the resistors for SLU, SLN, and SLT. So that's what we've done there. You can see that's labeled solenoids because that's the resistors to fool the solenoids over there. Okay, now the reason it's quite long is because these resistors get incredibly hot, so they cannot go inside the ECU box. So what we've done in this case is we've made this harness section here, so you can basically push it down. You can go to this rubber piece over here, cut a small slit in there, push that connector through there, and then you can put the other end, which has the resistors on, behind the headlight here, tuck it all nice and neatly away where the resistors aren't going to do any damage when they get hot. And believe me, they do get very, very hot. Okay. Another problem with the US ECUs is it does cause a check engine light with the secondary oxygen sensors being removed. So as you can see here, we fitted an O2 sensor emulator. So this is going to take care of the signals for the secondary O2 sensors. So again, it's nicely unplugged there, labeled O2 over there. But again, there's only this 4-pin plug and that 6-pin plug, and everything else is unique. So again, you cannot actually get any of the connections wrong because they simply won't plug into anything else. Okay, so super simple there. Obviously, like I said, you saw the picture earlier of what it looks like when everything is all nicely tucked away. Moving along from there, we then have our grommet, which slots directly down into there. And obviously that rubber grommet keeps everything nice and sealed in the box, so you don't get any water in there, which is great. Moving along from there, the harness then runs along, a little bit of rubber over here, and then we get to a piece of plastic at the back of the engine. Okay. So what we're going to do first is we're going to go over to this side over here, and then we'll come back and we'll go that section over there. So just a small section over here, which goes over the fuel pulsation damper. And then we end up in our second piece of plastic that's keeping everything all together. There's a mounting bolt there and a mounting bolt there, and that's basically all that's required to put that onto the intake manifold. Super simple. Now, there's 3 sections that pop out the front over here, and that is going to be this one over here, which goes to injector 7 and coil 7. Now remember, when you're looking at these engines, you're always looking from the driver's perspective, so basically from the back of the engine forwards. And this is the left bank, or bank 1 as it's called, because it has cylinder 1, 3, 5, and 7. The other side is the right bank, or bank 2, because it has 2, 4, 6, and 8. Okay, so basically that is the cylinders as they go. Obviously, I'll be going through it as I go through the layout, but just to give you a heads up as to exactly what each cylinder is and how to identify it. Right, the next breakout over here is going to go to injector 5 and coil 5. Super simple. And the last breakout is going to go to the cam sensor on the inlet cam for the VVT. So remember, this is a 1UZ VVT-i. The 3UZ VVT-i is exactly the same. There's VVT-i only on the inlet cam, not on the exhaust cam. And this sensor over here reads 3 teeth on the inlet cam, so the ECU knows how much the cam is being advanced or retarded, depending on what the ECU is commanding. Okay, then we have injector 3 and coil 3. And while I'm here, obviously we have 3 cam sensors in total on the 1 and 3UZ VVT-i, which we'll go through as we go through the rest of the layout. Right, when that comes to an end over here, we then have our connector for our purge valve. That's a little vacuum solenoid valve that's bolted onto the inlet over here. We also have our noise filter. So again, this is just a capacitor. It gets bolted to the inlet manifold. That's how it gets its ground. That's the 12 volts that supplies the injectors and coils, and that absorbs any noise caused by the injectors and coils firing or pulsing as they do. Okay, then moving along, the harness goes along till here, and it breaks out at the front over here, and it's going to go to injector 1 and coil 1 over there. It's also going to go to the oil control valve for the left bank, so that's that connector over there. Okay, it's going to go a little bit further on, which you can't really see underneath. It's going to break out, and it's going to go to the TPS connector. So this is obviously not a standard Toyota TPS connector. TPS sensors down there, and there's a little sub harness which you can see over here or over there, which runs down and connects to the TPS sensor. So this is how it interfaces with the TPS sensor. Also coming out of there is then your accelerator position sensor. So as you can see over here, here is the connector here. This is where your accelerator cable goes. Now, unfortunately, or not unfortunately, but a 1UZ VVT-i is a full drive-by-wire system. So you can see I'm not actually moving the throttle blade until I get to about here. Okay, this whole first section, you're not moving the throttle blade. It is a drive-by-wire system. So this is an accelerator position sensor, okay? So that's how the drive-by-wire system works. You do have an override on these early ones, and that's the little section there at the end where you can actually hear the throttle blade moving as well. But here's your motor to run your drive-by-wire. Which brings me on to my next breakout over here, and that is your drive-by-wire motor. All right, now there are 4 connectors. 2 of them are for the actual motor itself. The other 2 are for the clutch. So the way the Toyota built the safety into this is if there's a problem with the drive-by-wire, it will disengage the clutch and therefore disengage the motor from the throttle blade, so that if there's an error either with the accelerator position sensor or the TPS signals and it's not happy, it'll disengage the clutch, and no matter what the motor does, it'll be completely disconnected from the throttle blade itself. So that's the safety that's built in with this drive-by-wire system. It's the same on the IS200, the 1UZ-FE. It's exactly the same as the one on the 2JZ, GE, and GTE VVT-Is as well. All drive-by-wire, all have a clutch, all have a motor that's controlled like that. Right, also coming out here with the drive-by-wire connector is your front cam sensor. Okay, so this is the second of the third cam sensor, and basically this one is reading a single tooth on the cam pulley in here. So the ECU is able to determine the engine position for obviously fully sequential injection and ignition. Okay, so the ones on the VVT-i inlets, that's so the ECU knows how retarded or advanced the cams are. This is the one that it uses to obviously pick up engine position to know when to spark and fire the injectors. Right, moving along from there, we then have the harness run down here. There's 2 mounting points there and there. Obviously, I've just got clips that I can quite easily take it out because obviously I'm pulling them out all of the time. When we come down to here, we then have a breakout that goes into 3 sections. So first section over here is going to be our AC connector. Okay, so this is going to plug into the AC pump. Again, because it's plug and play, we can make the AC work. We'll do part of the testing when we look at the testing. When I actually test with the ignition on, you'll see the test that I go through to make sure that everything is working correctly. Okay, and also with the AC, even the idle up works as well. Next, coming out of here, you'll see this very thin wire, and that is going to our oil pressure switch over there, again labeled oil. So again, these are the ones that the new harness sections that we added in that you would have seen in the photographs earlier. Okay, now obviously this is actually an LS400 engine. It's not a 1UZ VVT-i engine. On a 1UZ VVT-i engine, which has the correct oil filter housing to fit into an IS200, but this switch is actually facing backwards. That's why it breaks out of the top over here, so it can come down. It can go through here. Remember, your aircon pump would normally be here. It can go through here, down to the back, and then plug into the oil pressure switch over there. Right, then the next section is going to be this one down here. It's taped up. It's obviously the original harness section, and it goes through, down through here. Let's see if I can grab it. There you go. Down to there, and it goes to your crank sensor. Okay, so again, all these different plugs, so you can't really get it in the wrong place, but that is your crank sensor down there. Okay. And also with the crank sensor on the VVT-i models, it's a 36-2 trigger wheel if you're interested in that information, unlike the non-VVT-i that had 12 teeth with no missing. All right, now that we've done that section, let's pop back over here, and coming down over here is where the automatic gearbox harness used to come out. So let's start going through what comes out there now. So first of all, we have our earth strap, okay? Now then, on the 1UZ VVT-Is, you'll have this bolt over here. You won't have the M10 bolt over here, that's for a 3UZ. So this is the one that you're going to be using. It's an M8 bolt, 12mm. We'll loosen that up and tighten that down for you. Now, these Toyota engines do love an earth. So what I always advise people to do is, because aluminium can rust and you get that sort of furry buildup, make sure you clean the surface with an emery cloth before you bolt this down to make sure you have a very, very good earth. Okay. Right, next up from there is going to be our new gearbox section. So as I said, this is running a J160 gearbox. So again, we have the gearbox section over there. Obviously, we put it on a sub harness because you guys like to change gearboxes from time to time. So if you were to change to like a BMW or a CD009 or whatever, you just unplug that and we can plug in a new section that will match your gearbox, okay? And don't worry about if you have a gearbox with no speed signal on it. Luckily with the IS200/IS300s, either if you have an automatic version of either of those vehicles, so whether it be an IS200 or IS300, the speed is actually coming from the ABS ECU. It's not coming from the engine at all. But luckily, the ABS and TRC and VSC ECUs are exactly the same across the board. So therefore, we can actually add that wire in, which will run from the ABS ECU to the cluster, and therefore you can get your speed from that. So even if you fit a BMW gearbox, we'd basically do you a connector with just the reverse light switch, and we would then be able to supply you with a wire to add the speed from the ABS ECU. Super simple. Okay. Also coming out here is then going to be our Lambda sensor. So that's down in the corner over there. Hopefully you can see the little piece of wire there. Now, obviously this does have a piece of fiberglass heat-proof sleeving on, but there is a metal shield which goes here between the exhaust and the block. And that connector is supposed to connect behind that. Now, please do make sure that you fit that back on. That is a plastic connector. If you don't fit that on and this then comes loose and falls on the exhaust, it will then melt, and there's a power and a ground in there. Obviously, that's going to short and it's going to shut everything down because it's the same power that supplies that supplies the ECU as well. Okay, so please make sure you fit that metal plate in there to keep that connector from touching the exhaust ever and causing that short. All right. Now then, so those are the only 3 sections now that come out the back over here. So let's carry on with the rest of it. Now then, the next plug you're going to see is basically the plug for the harness that goes under the intake, plugs into the 2 knock sensors and the starter solenoid. So what I'm going to do now is let's cut to a photo of that. So there you can see that's the overall picture, what it looks like underneath the intake. You'll notice there that we have actually, we're not rebuilt as much, but we had to put new connectors and new terminals on for the knock sensors. So I have heat shrink them up and I have labeled them so they're nice and easy to see. Okay, so next up we're looking at the starter solenoid. So we have a close up of that, and then we'll see knock sensor 1. Now knock sensor 1 refers to the left bank, or bank 1, as we mentioned earlier. Then we have knock sensor 2, and that refers to bank 2, or the right bank, as we referred to earlier when we went through what the cylinder numbers are. Okay, right, so coming back to the harness now, we also then have our main starter cable. Okay, now in this case, obviously the 1UZ VVT-i has a very, very, very long starter cable because it ran down there along the block to the front because the battery was located in the front of the engine bay. What we do now is we cut these short, we put a new ring terminal on, we have a proper hydraulic crimper to get that all nice and done there. So again, we put a new terminal on for you guys and we take it to the correct length. We basically make it the same as a 1UZ, which obviously has the battery in here like an IS200. Okay, right, so that's that section. Let's pop over to the other side now and we'll carry on from there. Excuse my voice, guys. Right, so this is, again, the plastic goes down through there. And one thing I haven't mentioned actually is because this is a 1UZ engine, I've got a 1UZ water bridge on here. So not all the mounting points are there, but you should have a mounting point there. There's a mounting point inside there where my finger is. Hopefully you can see that. And then there's a mounting point here. So this is shared between the 1 and the 3UZ, this mounting point. But those two are on a 1UZ, and a 3UZ only actually has one other mounting point, which is down where that bolt is over there. Fantastic. Right, so moving along to here, we basically get to the edge over here and we have another earth strap. So again, you're not going to have the M6 bolt, you're going to have the M8 bolt in there. Again, same rule as the other side. Take a piece of emery cloth and clean the surface before you put this back on again. Make sure you have a decent earth. And also on the IS200, there's an earthing point on the firewall over there as part of your brake booster vacuum hose over there. Now, obviously, you don't need that brake booster vacuum hose. This is what a GS430 has, but a LS400 would actually have a barb on here, which you can then take directly from there to your brake booster. But obviously, you can leave that over there because it is an earthing point over there. So you could use an M6 bolt and make the earth strap that was originally running from there to your 1G engine. And you can take it from there to the firewall and give yourself another earth. It's what Toyota do, so it's not out of the ordinary. And more earths basically help with these engines because they do love earths. Okay. So moving along to there, we then get to where the plastic ends and we start on this section over here. So the first one that's going to break out is going to be Injector 8 and Coil 8. Then we move along to over here. Next breakout section is going to be for the ACIS vacuum solenoid plug. Now in the description down below, I will put a link to a video where I actually go through the entire ACIS system. I actually pull an intake apart completely in half and show you what it looks like inside and how it works. So I'm not going to go through that now. But what I would say to you guys is, you're obviously going to be pulling the intake off to fit that harness that goes underneath. That's the perfect time to test your ACIS solenoid valve, okay? Now, if you look at this plug over here, you've got a white wire and you've got a blue with a white tracer. The white wire is 12 volts and the blue with the white tracer is ground. So if you convert it to the other side over here, you've got black and white. So black is 12 volts, white is ground. You basically use a battery and just supply these with 12 volts and ground, and you're listening for a click underneath the inlet manifold. You'll see the brown vacuum solenoid valve when you pull the intake off. Test it while it's off. If it doesn't work, replace it, because there's nothing worse than getting this all on, finding that your ACIS system doesn't work. Then you have to pull the whole thing off again to rectify that, okay? Also coming out of here is then going to be obviously Injector 6 and Coil 6. We move along to over here, and then we have the breakout for Injector 4, Coil 4, and the third cam sensor measuring the VVT-i on the right bank inlet cam. Okay, then we move along to over here, and we have another breakout section over here. Quite a few bits coming out over here. But first of all, we have our coolant temperature sensor. Now, if you look at your engine, you won't have this temperature sensor. You should have a blanking bolt in there. Don't need to worry about it. You just leave it exactly like that. You don't need to put a temperature sensor in for this particular harness. All right, we also have the Injector 2 and Coil 2. And you notice here there's some bolt holes there. You could use some P-clamps over there to hold the harness nicely in place over here. All right. Last section that's going to go to a connector over here is going to be your oil control valve for your right bank. Okay, so that's over there. Okay, now then, what you'll notice is the mass airflow sensor used to come out down about here. I bring it up to here so you guys have some more room to play with, but that is going to go up to our mass airflow sensor. All right, so be very careful with mass airflow sensors, especially with the 1UZ-FE VVT-i. Again, it's not going to apply to everybody, but if you have an LS400 or a Celsius, you're definitely going to be having this style of mass airflow sensor. I call it the bullet because if you take a look from there, it looks like a bullet over there. So that's just my nickname. It's not a Toyota nickname or anything like that, but that's this one. What you have to be careful is you do have Crown 1UZ-FE VVT-i's and the GS400, I think, in the United States, and they used this style of mass airflow sensor. Okay, now this one and this one have completely different wiring. So if you try to plug this sensor into this plug, I think you end up blowing the intake air temperature sensor circuit because you feed 12 volts down there. So be very, very careful. If you're ever unsure, go on Toyota DIY, take your ECU part number, okay, put it into Toyota DIY, go to the air cleaner section, and it'll give you the part number for the mass airflow sensor, okay? And then Google that part number and you'll see whether you have this style or whether you have the smaller style, okay? Right, so moving along from there, the harness is now going to run down the bottom over here. And it's going to split down here at the bottom and it goes to the alternator plug. That's your 3-pin alternator plug over there. It goes to your oil level sensor. So remember, you have a front sump on a 1UZ-FE VVT-i from LS400. So your oil level sensor is going to be here at the front. So that's why that comes out there. And then lastly, coming down there, we go to our Lambda sensor plugs. Remember, we're only using the 2 primary Lambda sensors, this one and the one on the other side, okay? These share the same part numbers, but down below the description, I've actually put a ton of part numbers for a whole load of things there for you guys, from timing belts to injector seals to you name it. It's all down in the description there. Bunch of part numbers for when you guys are prepping your engine ready for install, okay? Right, so that's basically the harness side done. So there is some other things that you do need to do, okay? So first of all, we have our alternator. So it's this main one that bolts on over here. Obviously, that is not part of the 1UZ-FE VVT-i engine harness. It's gonna run down along your subframe. Now, this is where it gets important. You do need to connect it to your fuse box, okay? So basically, this is where the alternator goes because it gets fused by the 120 amp fuse, okay? So make sure you connect it there. Because the cable is running underneath along the subframe and up the other side, if anything was to go wrong and it was caught or rubbed through and shorted out, that fuse would blow and the wire wouldn't heat up to the point where it actually set fire. So again, super important to connect it there. Don't connect it directly to the battery because if it shorts out, there'll be no protection from the fuse. And it doesn't really make any sense because it's right there. You've got the mounting point there, and it's about literally maybe 5-6 inches away from that one, so no excuse to add it onto the battery there instead of there. Right, so that's the power for the alternator. Obviously the starter main power is built into your sub harness, which obviously you do get with this particular engine harness. The next one is going to be your grounds, okay? So again, we spoke about the grounds on the back of the engine, so you've got there and there. I do advise you to take your IS200 ground from the firewall to that cylinder head on that side over there. That always helps. But obviously your main ground is this one that goes to the battery. It goes down underneath the battery and bolts to the chassis. And while the engine's out, that's a really good time to pull up your battery, unbolt the plastic tray, pull that out and take a look at the condition of that earthing point. Because that earthing point from there to the chassis, that's the earthing point for your entire vehicle. If it's all rusted or water settled in there, get it nice and clean, give it a good rub down, make sure it's nice and clean earth, bolt it back down again, okay? Then next up is the earth cable goes along down there. And I'll see if I can actually, there you go. There's the original IS200 cable over there. Obviously I don't use it because I've got earth already bolted to the engine, but that you can then bolt to the block. Okay, so that's the main earth, and that's obviously what the starter motor, everything is going to earth through. as well as the engine harness, but obviously you can add another earth from there just to help the engine harness out to make sure it's got a good earth. Okay. Now then, if that cable is too small, you find, or you're having issues with it, obviously make sure your terminals and your battery are clean. There's absolutely nothing wrong with you adding another earth like I've done over here. I've got a nice big thick earth cable over here. Go straight down there, straight to the block, and I take it to the battery negative terminal. Again, there's absolutely nothing wrong with doing that. If you do want to do that, knock yourself out, do it. Okay. Right. So I think that covers everything. We've gone through the entire harness, where everything plugs in, what it does, and how it works. We've also gone through the alternator connection to the fuse box. We've gone through the battery connected to the starter, which is part of your harness over there. And obviously we've gone through the earths. So basically that's the only thing that you guys need to connect over and above the engine harness itself. Everything inside there just plugs directly in and off you go. Okay. Right, so that's that whole section done. So next thing I'm going to do is I'm going to get it ready for testing, and we're going to come back with the testing with the ignition on. So see you in a second. Right guys, now we're back for the testing of the engine harness, and as I said earlier, it's made up of a section with just the ignition on and a section with the engine actually running. Okay, so first we're going to go through the entire test, then we'll jump into the ignition on, and then obviously we'll move on to the engine running test. So first, the ignition on test, we're going to be testing the immobilizer. So obviously we've removed the immobilizer on the ECU. We still wire everything up so it still looks like you have an immobilizer. Obviously your security light's still flashing, as you can see over there. So again, anybody walking by the car will think that there is still an immobilizer on the vehicle, so hopefully that should deter anyone from trying anything. Then next up, we're going to have ambient temperature. We're going to go over to the climate control device over there, and we're going to check and see if we have the outside temperature displaying. Now, in this particular setup, it is actually connected to the engine ECU. It's one of the things that the MPX device is translating over, so it is actually sensed, and it will go up and down as the outside temperature goes up and down. Then we're going to come over to the cluster, and we're going to do the check engine light, the charge light, and the oil pressure light. So they're all going to light up on the dash there. Obviously, when we start the engine, they're all going to go out, and then we make sure that they are actually working. Okay. Then for the gearbox section, we're going to test the reverse and the speedo. So again, super simple. I've just got a wire in here in the reverse plug, and I've got my device in here for the speed sensor plug. So we're just going to feed those signals in, and we're going to test and make sure that they are working. Then OBD2 test. Basically what I'm testing is, this is nothing out of the ordinary. It's going to utilize your standard OBD2 connector that's inside the driver's footwell over here, exactly as you would before when it was an IS200. You're going to plug in there. You can use TechStream. GTS is what I use. Basically, it's a subscription. I pay €7 for a day, or you can have a day, 15 days, a month, a year, etc. But that'll give you full Toyota diagnostics, so you can see everything from live data, carry out active tests, exactly as you see here. You can also normally use those Bluetooth dongles. I think with the LS400, some of them do work, some of them don't. I don't have an extensive list, unfortunately. But as I said, the way that this is basically wired in, you could literally drive into a Lexus or Toyota dealership. They could plug in TechStream, and they could read the ECU as though it was a car that was made by Toyota or Lexus. Okay. Next up is fuel pump relay. So in this case, the fuel pump is being controlled via the engine ECU. Down in the description below, I have a link to a video explaining how the fuel systems work. So there's a lot of useful information in there, so I do suggest you go and watch that. So basically, the major one that I always keep getting asked is, why does the fuel pump not come on when I turn the key ignition on? That is completely standard. It didn't do it on your IS200, and it's not going to do it on this either. They are not a priming system. The fuel pump only runs when it picks up that the engine is cranking over, and it'll continue to run as long as the crank sensor is picking up that the engine is rotating. Okay, that's the only two occasions the fuel pump run. So again, you just didn't notice it on your IS200 because you never checked. But yeah, IS200 is exactly the same. No fuel pump prime when you turn the key on, only when you crank over and so on. That's why there's a check valve in the fuel pump system in the IS200s, and they share the exact same system here. It's a deadhead system. You only have one fuel pipe coming to there. Regulation is taken care of inside the tank. So you basically just connect your IS200 fuel line directly up to there. If your pump is incredibly old, you might want to consider changing that. There's also a filter inside the fuel hatch. So again, you might want to consider changing that if you have a very old vehicle and it's never been done before, because it usually isn't. It's not something that gets done. Okay. After that, well, basically we're going to go into GTS here. We're going to activate the fuel pump relay so you can hear that the fuel pump is working. And then lastly, we're going to do AC clutch and AC request. So the two tests there basically is, I've got the live data over here. You can see I've got AC signal over there. I'm then going to basically go press the AC button on the climate control, come back, and you're going to see that signal is going to go from off to on. And then obviously I'm going to go press it again, and you're going to see it's go from on to off. Okay. An extra test I do outside of the video is when the engine is running, I actually press the AC button to make sure that the idle up works. So again, that does work as well. Now with the AC system, you do need to have everything connected as though it was an IS200. There's a pressure switch in the front of the vehicle. That is what is going to go to the engine ECU, in this case, the 1UZ-FE VVT-i. And that's going to tell the ECU whether the pressure is correct to actually activate the AC magnetic clutch relay. So the engine ECU is controlling the AC. It's just taking signals via MPX from there to there to tell it exactly when it wants the AC to run. Okay, so that's the ignition on testing. Obviously, it's quite an extensive list over sort of just a wire up harness because we'll be testing a bunch of stuff in the vehicle as well. Then next up, with the engine running, we're going to test the starter circuit / neutral start switch if it's an auto. But in this case, all we want to basically see is when we turn the key to the start position, that all the wiring inside is correct and the engine will crank over. Because even though the IS200 was originally a manual, or even if it was an auto or a manual, there's still a neutral start switch wiring even in the manual harnesses. We need to make sure that that is done correctly. So again, that's what we're testing there. Then the ACIS. So basically what we're going to be looking for there is we're going to be looking for this valve to go like that. And it does it a few seconds after the vehicle starts. So again, we'll just pan over and make sure that that is working once we've started up the engine. Next up is drive-by-wire test. So that's a very simple test. I'm basically just going to come over here and I'm effectively going to pull the accelerator. If I pull it just that little bit and the engine revs up, I know the drive-by-wire is working because, as I said earlier, that actual thing where you put the accelerator cable on is not connected to the actual throttle blade itself, only at the very end as a sort of override from there. Okay. Oil control valve VVT-i test. Again, we go over to GTS. I'm basically going to activate the oil control valves on bank 1 and bank 2. It's going to cause the engine to run lumpy, so that's what we're going to listen for on the sound, and that's going to tell me that the oil control valves are working 100%. I don't know if I ever mentioned it before, but the oil control valves, like a 1G and a 2JZ, do have a filter, and it's built into this cam cap over here. It's a bit of a pain to clean out, but if you're going to prep a whole engine and you're doing cam cover gaskets or whatever, again, you could possibly take that out and give that a good clean to make sure that everything is okay, especially if you suspect that the engine has not been serviced regularly and had regular oil changes. Next up is going to be injectors and coils. So actually what I'm going to be doing is I'm going to be disconnecting each injector one by one. That's going to then, you're going to hear the engine misfire as I do that. Plug it back in again, it'll idle smooth. And I'm going to do that for every single cylinder, and it's going to tell me that every single cylinder is firing exactly as it should do. Then we're going to go over to tacho. So basically all I want to see is when the engine's running that the tachometer is working. Now that little MPX device over there is actually converting the 4-cylinder signal from the 1UZ-FE VVT-i to a 6-cylinder signal, which is what the IS200 needs to operate the tacho correctly. Okay. Then we're going to go look at the coolant temperature. So I normally like to keep the coolant temperature quite low when I do the video for the testing. So basically, as we go through the whole section as the engine's running, hopefully that does warm up a little bit so we can look at the start. And then obviously when we come to the end, we'll have a look again and you'll see that coolant temperature does go up. So that's basically what we're looking for there. And then lastly, we want to go on to diagnostics. So obviously we've taken care of everything with the Atomu, with the O2 emulator and the resistor. So we should have absolutely no diagnostic trouble codes at all. You should have no check engine light on when it is running. So basically that's what we're going to be looking for. We're going to go over to GTS. We're going to check the DTCs or diagnostic trouble codes, make sure there's nothing there. And when the engine is running the whole time, you'll see the check engine light does go out on the dash. So that's, again, fantastic. And there's some other thing with diagnostics I'll go through as well at the time when we finish the running test. All right. So now that we've done that, let's jump into the immobilizer test, okay? Now, I've done a video on a couple of harnesses on the immobilizer system and how it works, but basically, on your IS200 or your LS400 and so on, there is a wire going from the key barrel to the ECU to tell the ECU to turn on to read the key. So what I mean by that is, the second you insert the key, it's going to then check for the key and it's going to then turn off the immobilizer, okay? In this case, we don't have an immobilizer, but what you're going to see now is I'm actually just literally going to insert the key. I'm going to try and get it all in one go. You can see the security light flashing there. Let's see if I can get the key in there as well. And as I insert the key, now some of you may have heard a relay click over there in the fuse box. That is correct, but you can see the security light has now gone off. I haven't turned the key, ignition's not on, I've just inserted it, and you can see that the ECU actually activates. And in a case where there was an immobilizer, it would look for the key already, okay? So again, in your IS200, if you guys ever wondering what's happening, you just need to insert the key and your security light should go off. That's exactly how it should work, okay? Right, so let's turn the ignition on, and let's go over and look at the ambient temperature. So let's just move this out the way. And there you go, 16 degrees, perfect. Okay, as I said, that is actually being sensed by the ECU, so they will go up and down. So that's the temperature currently here in the workshop. If it was 20, it'll show 20. If it was 5, it would show 5, okay? Right, so next up is gonna be check engine, charge light, and oil pressure. As you can see there, we've got check engine light, we've got oil pressure, and we've got charge or alternator light on there, okay? Now, what you guys will need to do while I'm on the lights here quickly is the TRC bulb. You need to remove the TRC bulb, okay? Again, the LS400s and the 2JZ IS200s, they used VSC, not TRC. The TRC that's in the IS200 is a very antiquated system. It basically just shut the throttle down if it detected slip. So these two systems cannot communicate with each other because they are very, very different. So you do need to remove the TRC bulb from your cluster. Otherwise, it is just going to continue to flash at you. And obviously, just note that there is no traction control or VSC or whatever active with this particular setup. Okay. Right, so next up, let's go to the reverse and the speedo. So all I'm going to do now is mimic what your gearbox is going to do. And I'm going to basically short out this. And you can hear the usual beep of an IS200 reverse indicator. So obviously the reason I put the wire in there is to make sure that the crimps on the terminals are safe and correct. Make sure that all the connections in there are correct. And make sure the connections already in the ECU box are correct as well. Okay. But that's the reverse. So again, as long as your gearbox is working and the reverse switch is closing when you put it into reverse, your reverse lights will come on and you'll get your beep over there. Okay. Now let's move on to the speedo. And if you've seen any of our other videos, you'll know exactly what we're doing now. So basically all I'm doing now is putting it into test mode, which is a lot easier with two hands. Okay, let me try that again. All right, so you see it's in test mode now. And the reason I do this is because this is what we call a Hall effect style sensor. So pin 1 is 12 volts, pin 2 is ground, and the ground actually goes directly to the cluster. And the third one is the signal in for the speed, okay? So what I'm gonna do now is I'm gonna try and get it all on camera at the same time. But basically there's the speed sensor. And as I touch the signal on there, you see the speed sensor is going up and down there, okay? So that is perfect, exactly what I wanna see. Right, so little hint for you guys, if you get this all done in, sometimes with the guys when they're putting in the engines, they take them in and out and in and out and in and out. And you obviously have to do modifications to the gearbox, etc. If you find when you plug it all in and the speed is not working, there is a quick, easy way to test it without having any sort of fancy equipment. But basically what you can do is you can put the ignition on, get your buddy to sit inside the car. You can unscrew the speed sensor in the back of the gearbox. Now it's basically a worm gear. So what you can do is basically tape it to the end of a drill and just spin it with your drill. If you get speed coming up on your dash when you spin the speed sensor with a drill, then clearly the problem's inside the gearbox because that wheel is not turning. If you then spin it with your drill and you get no speed on the dash, then go ahead and check that your speed sensor is working. If you've got another one, try another one. If not, the major issue you're probably going to find is that basically the same power supply for the speed sensor and the reverse switch is the same power supply that's for the cluster as well. So if other stuff on your cluster dies and you're not getting speed, check that you're getting reverse. If you're getting reverse, then that means the 12 volts to the system is correct. And then obviously you can move from there, testing things like the earth, testing things like another speed sensor, etc. But that's a quick, easy way to test without having to have any sort of fancy equipment there. Right, so OBD2 test, let's pop onto that. So what I'm gonna do now is, I'm just gonna go onto there. So what we're looking for here is, I've connected to the ECU, and you'll see that we do have some data on there. So you can see our coolant temperature is currently at about 48 degrees. So you should see our needle is just slightly off the bottom there. Starts reading at about 40 degrees. It starts moving off the needle over there. So that's all correct. So again, we're able to communicate with the ECU, absolutely no problem at all. And obviously we can check DTC. So that's the OBD2 test, all done and dusted without any major issues. Right, so let's go over to the fuel pump test. So as I said, it is being controlled by the ECU. Now if you see here, it says fuel pump, relay, and fuel pump. If you watch my video, you'll understand why that is important, that we don't test the fuel pump relay and just the fuel pump. So let's go ahead. I'm going to keep quiet now and move over to there. So hopefully you heard the fuel pump running there. So again, I'm able to turn the fuel pump on and off with the ECU, which is exactly what we want to test there. Let's go over to AC clutch. So while I'm in the testing, I can test the AC magnetic clutch relay. And again, that relay is located next to the ECU box. So again, I'm going to keep very quiet and hopefully you can hear this. I'm going to try and move the camera closer to there. Okay, so hopefully you heard that I activated the relay a couple of times there. But again, that relay is literally in that box over there. So that's where your AC magnetic clutch relay is over there. Right, so let's move on to the AC request. So now we want to go on to data list. We want to obviously see live data. Let's go over to my testing one so we don't have 100 yards of data over there. Right, so at the moment you can see our AC signal is off. I'm going to come over here, I'm going to press the AC button, lights up on there. And our AC signal has now gone to on, which is exactly what we want to see. Let's go turn it off. And our AC signal has now gone to off. Fantastic. So now I know that the MPX device is doing its job. It's translating the AC signal from the car, the climate control, to the actual engine ECU itself. So provided everything else is okay, for example, that obviously the pressure is okay, and all the other requirements are met, the ECU will engage the AC magnetic clutch relay. So that's what we're testing over there. All right. Right, so now that's finished testing. Now what I'm going to do is get my ear defenders and everything ready. We're going to come back and we're going to do the testing with the engine running. See you in a second. All right, guys, so now we're ready for the testing of the engine with it running. So quick recap what we're going to be doing. First up, starter circuit, making sure it turns on the key. ACIS, we're going to check the valve at the back once it starts. Drive-by-wire test, we're going to rev the engine up. Oil control valve, we're going to pop over here and do those two tests for bank 1 and bank 2. Injectors and coils, I'm going to go and remove each injector one by one to hear the misfire. Tacho, we're going to make sure that our tacho signal is working on the dash there. Coolant temperature, well, we've already seen it come off the needle there, so we want to see how far it goes up when I finish all the rest of the tests. And then diagnostics will come at the end there. Okay. Right, so without further ado, let's go ahead and crank this over. There you go. See, check engine light's gone out. Battery light's gone out, oil light's gone out. Fantastic. Okay. ACIS, that's gone down, so that's perfect. Drive-by-wire test. Perfect. Okay. Oil control valve test. Fantastic, so that's oil control valve. Let's go over to the injectors and coils now. We'll start on this side over here, so that's number 2. Number 4. Number 6. Number 8. Over to this side now. So we'll test number 1. Test number 3. Number 5. And number 7. Great, okay, so that's injectors and coils. Alright, so tacho. Perfect. Right, so cooler temperature, let's take a look. You can see that's gone up, so that's perfect. Alright, and let's go over to DTCs. Let me just take the fuel pump off quickly. Okay. Right, so you saw the check engine light stayed off the whole time the engine was running. It's great because we've taken care of all the signals. Anything that will cause check engine light has been taken off. We can see on the ECU that according to our diagnostic trouble codes, we've got absolutely no codes whatsoever. So again, this is plug and play. If the engine light does come on, there is a problem that needs to be resolved. So you need to either plug it in or you need to obviously get that live data and the diagnostic trouble codes from a laptop or text stream or a handheld device or a Bluetooth dongle or whatever you're going to use to do that, okay? Now, unfortunately, because this is an American ECU, we can't do the old trick of bridging the two terminals and OBD2 port. It doesn't work with the American ECUs. Unfortunately, it only works with the European and the Japanese ECUs. So in this case, you're going to have to rely on diagnostic software in order to talk to the ECU to get all of those trouble codes off, okay? Now then, with the diagnostics, there is another thing that you can do by bridging those two terminals. And those two terminals that I'm talking about are basically pin, I think, 4 and 13 on the OBD2 port inside the car. I think 13 is TC and 4 is just a ground, so you're grounding out TC. If you have an IS200 that's before 2001, you also have this diagnostics port in the engine bay. And if you take a look here in the lid, you'll see E1, which is that one over there, and TC, which is that middle one over there. So you can bridge it there or inside the vehicle. But if your IS200 is after 2001, you don't have that diagnostic port in the engine bay, okay? Right, so if you bridge those two terminals, it's going to put the ECU into diagnostics mode. And the only reason that you really need to do that on your particular engine is if you want to check timing, okay? So without having to remove these covers and take a look and see what's going on with the timing, you can do it by bridging those two pins, because what happens is it locks the timing at 10 degrees, okay? Now in my case, I've got a gun, I can just put the clamp around the wires for the coil. I can then obviously take the timing light, I can go over here, and I can check my timing. So if you take a look at your cover over here, you've got 0, 5, 10, and 15 degrees. So that's your timing marks on the case there. And if you take a look on your crank pulley, which I think unfortunately in our case is right behind here. Let's see if I can, it's right over there. I don't know if you can see it there. Yeah, it should be bright white. Basically, I've used Tip-X correction fluid and I've effectively marked that up so you can really see it nicely with the timing light. But yeah, so if you put it into diagnostic mode by bridging those two pins, you can check the timing is at 10 degrees, okay? If it's not, then you can pull all these covers off and actually check the mechanical marks, okay? Now, obviously, you're only looking for this problem if you have some sort of weird running issues and you want to make sure the timing is correct. Just a really quick, easy way to do it without having to remove a single bolt. Take a paper clip, bridge those two things, start it up, get your timing light out, see if you're at 10 degrees. If you're not, something's wrong. If you are, timing is not an issue and the engine is firing exactly when it should. Which brings me on to my next point, is do not leave the paper clip or piece of wire in there, because obviously if you're locking the timing at 10 degrees, the engine's going to run really, really badly and you're going to have no power whatsoever, okay? Right, so that's it for this harness. Obviously everything is on here, everything is working exactly as it should. Super happy with everything at the moment. Now we've obviously got to get it boxed up and off to the customer so he can get it into his vehicle. If you guys have any questions, please feel free to comment down below. I try and get to them as often as I can. If not, you can email us at info@Phoenix Engine Management, or you can find us on Facebook. Just search Phoenix Engine Management and you can send us a message there. Now, obviously, for new inquiries, and you guys are going to get back to us, my initial first response is going to be a video that I will send you a link to. It's basically to help out with queries. So what I normally do is I ask you guys to send over things like the ECU part number for your original engine. It helps me to determine exactly what we're dealing with. And that applies even if it's aftermarket ECU, standalone, standard ECU, etc. It's just so that I know what engine we are dealing with and what particular model. Because as I go through in that video, if you send us a message, I'll send you the queries video. You'll see a lot of different models for the 1UZ, for the 3UZ, for the 1JZ, for the 2JZ, all of those. There are a lot of different models and they all have differences in wiring between them. Okay, but that's it, guys. And again, if there's anything you'd like to know, anything you're coming across or you want me to make a video of it when I next have a harness in, please let me know down in the comments. And I often make a bunch of short videos explaining sort of technical issues that you guys might be dealing with, because obviously these are really long videos that I go through now. But that's it, guys. Everything's perfect. Let's get off to the customer and we'll see you again soon. Bye-bye.